Hello everybody. In this video, we are going to talk about AMGM inequality, that is the arithmetic mean and the geometric mean inequality. So over here, suppose you have got some positive numbers, for example, x1, x2 up till xn. So all of them are positive, right? So AMGM inequality says that the arithmetic mean of them is every time greater than or equal to their geometric mean. Correct? So you see over here the arithmetic mean will be what? The sum of them divided by the number of observations, that is n over here, and that is greater than or equal to their geometric mean. Geometric mean is what? The nth root of the product of them, nth root of x1, x2, dot up till xn. So AM is every time greater than or equal to the GM. I hope that is clear over here, guys. So for two numbers specifically, and yeah, one more thing, the equality will hold when the numbers are equal. When you take x1, x2 and all of them to be equal to xn, then this equality will hold. Otherwise, AM will be greater than the geometric mean. Now for two numbers specifically, I will prove the result. You can see over here. If you have got two positive numbers greater than, two numbers greater than 0, then their arithmetic mean will obviously be greater than equal to their geometric mean. Correct? It will be their second root, because over here we are talking about nth root. Correct? Now how will we prove it? You see, the proof is also pretty simple. If you take x minus y the whole square, can't we say that it is every time greater than or equal to 0? You see, x minus y the whole square is every time positive and it will be equal to 0 when x is equal to y. I hope that is clear. So you see over here, can't we add 4xy over here on both the sides of the inequality? We can add 4xy. So you see, if you just simplify this thing, x minus y the whole square plus 4xy, you know algebraic identities, this will come out to be equal to x plus y the whole square. And you see that is greater than or equal to 4xy over here. Correct? Now you see, each of these is positive. This is positive as well as this is positive. So I can take the square root of both the sides of this inequality. What will I get? I'll get x plus y, that is greater than equal to 2 times of square root of xy. Right? So I can take 2 in the division over here. So I've got x plus y by 2, that is greater than equal to square root of xy. So haven't we proved that AM, this is the arithmetic mean of two positive numbers, is greater than equal to their geometric mean? So that is the simple proof of it, right? So let's do some simple questions on the basis of this property, AM is greater than equal to the geometric mean. So for example, you've got this question, they are telling you to find the maximum value of this for all positive A. Maximum value of this for all positive A. So basically this expression, can I write like this? 2 minus if I take common from here, I'll get A plus 1 upon 2A. So I want the maximum value of this expression. So you see, this thing will be maximum if this thing is minimum. I hope you understand that, because it is 2 minus this thing. So this whole expression's value will be maximum if A plus 1 by 2A is minimum. Now how will you find the minimum value of A plus 1 by 2A? So you can use AM greater than equal to GM property. You see this, AM is greater than equal to GM. So arithmetic mean of this and this, it will be what, guys? It is A plus 1 by 2A upon 2. And that is greater than or equal to the geometric mean of A and 1 by 2A will be this. So you see, this will be cancelled out. So from here, can't we say that a plus 1 by 2a is greater than or equal to, this will go on the other hand side, 2 times the square root of 1 by 2. If you just simplify this thing, this is going to be root 2. So what does it mean? That a plus 1 by 2a is greater than equal to root 2. It means the minimum value of a plus 1 by 2a is root 2. So therefore the maximum value of this expression is what? When a plus 1 by 2a is minimum, which is root 2. So the maximum value of this expression is 2 minus root 2. If it is specifically mentioned that a is positive. I hope this is clear. Okay, so let's move on to the next one, guys, over here. It is given that if you have been given with 3 positive real numbers a, b and c, which are in AP, such that ABC is equal to 4. You have to find the minimum possible value of B. So again we can use AM is greater than equal to the GM. So you see over here, the arithmetic mean of ABC is what? A plus B plus C by 3. Right? And that is greater than or equal to the geometric mean of them, cube root of ABC. I hope that is clear. It is greater than or equal to the geometric mean of ABC will be the product of them and their cube root, right? Now you see it's also given that ABC are in AP. So can't we say over here that 2B is equal to A plus C? If you know this concept already, if 3 numbers are in AP, then twice the middle number is equal to sum of the first and the last. That's a very direct thing, right? So in place of A plus C, I can put 2B over here. In place of A plus C, you can put 2B plus B upon 3, and that is greater than or equal to ABC is also given to us, that is 4. So it is, you see, 1 by 3rd power of 4 over here, right? So you see this is nothing but 3B by 3, or you can say B itself. And that is greater than or equal to, this is 2 square raised to the power 1 by 3 or 2 raised to the power 2 by 3. So B is greater than or equal to 2 raised to the power 2 by 3. So the minimum value of B is what? The minimum value of B is 2 raised to the power 2 by 3. So that was a direct question on AM-GM inequality. Like if you know this property, you can do it. If you don't know this property, then it can become very tough. I hope this is clear, guys. Now let's see the another question. This is kind of tricky question on the basis of AM-GM inequality. So over here, you have to find the minimal value of this function or minimum value of this function, whatever you might pronounce it, right? So basically over here, it is not very much, visible or very much obvious that you have to use AM-GM inequality. But this is also an AM-GM inequality question. We have to do a bit of manipulation in this expression so as to fit it in the case of AM-GM inequality. The simple hint over here is, you see, the product of them is 1. Product of x by y, y by z, and z by x, that is equal to 1. But you see over here, they are in different types of roots. This is square root, this is cube root. So how will I be able to change it such that I use this logic over here in AM-GM inequality? So for that, we have to do a bit of manipulation in the function over here. So the main thing is I want to remove the square root as well as cube root. I have to think like that so that the square root and the cube root gets removed over here. So how can we proceed with that? See this, the same function, can I write it like this? X by y plus, you see this over here, can I write it like this? Half of square root of yz plus half of square root of yz. Yes, you can very well do that. Plus, can I write this thing? Can I break it into 3 parts like this? 1/3 of cube root of z by x plus 1/3 of cube root of z by x plus 1/3 of cube root of z by x. Correct? Now, if I want to say AM is greater than equal to GM, so AM will be what? Sum of the observations divided by how many are they? 1, 2, 3, 4, 5, 6. Now, 6 observations are there, right? I have changed this into 6 observations, and that is greater than or equal to their geometric mean. That is greater than or equal to their geometric mean. So, what will be the geometric mean of these observations? It will be what? The product of all of them and their 6th power. So just see it very patiently. If you multiply this, first you see if you multiply these two, this will remain as it is. You see x by y will remain as it is. If you multiply these two, you see square root of anything, the whole square is the same number, right? So if you multiply these two I'm talking about. If you multiply these two, square root will be removed. So you'll get y by z over there. And if you multiply these three, this, and this, so cube root will be removed. It will be z by x over there. And then what about the numbers? Then the numbers are, you see, 1 by 4, and then 3 3s are 9, 3s are 27. So 1 by 2 square and 1 by 3 cube. So it is 1 by 2 square, you might write it like this, 1 by 2 square into, that is 3 cube over there. And then you have to find the cube root. Cube root means 6th power over there, 1 by 6th power, right? So this is the geometric mean of them. Now you see these will be cancelled out. Yes or no? The product is 1 over here. So that was the manipulation which I was talking about. You understand, that is the manipulation which I was talking about. So what is the minimum value? This 6 will be cross multiplied. So 6 times of this thing, 6 times of cube root, 6 root of 1 by 6 root of this thing is the minimum value of the expression. I hope this is clear. This is the answer over here, right? You can obviously manipulate the expression if you use laws of exponents, that is 6 divided by exponents will be multiplied. So 2 raised to the power 1 by 3 you will get, and over here 3 raised to the power 1 by 2 you will get. This is the answer over here, right? So you can obviously further manipulate it. Let us manipulate it. That is 6 upon 2 raised to the power 1 by 3 multiplied by 3 raised to the power half. So how can I, you see the denominator is an irrational number. Let's make it a rational number. Can I multiply by 2 raised to the power 2 by 3 and 3 raised to the power 1 by 2 in the numerator as well as the denominator? Why I am doing that? Because you see, if you multiply this and this, 2 raised to the power 1 by 3 and 2 raised to the power 2 by 3 will give you 2, right? And 3 raised to the power half into 3 raised to the power half will give you 3. And then 3 2s are 6. So basically this will be cancelled out by this 6. So the minimum value is 2 raised to the power 2 by 3 multiplied by 3 raised to the power half. So that is the minimum value of this expression. Don't forget that you can use this property when it is given that all of them are positive. Then only you can use AM is greater than equal to GM property. I hope this is clear, guys. So that's all we needed to do over here on AM GM inequality. It's a very important result, guys. Very important, especially for Olympiads. That's all we needed to do. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever is discussed in live classes, you can get the PDF of those sessions after the class. Bye-bye guys. Take care everybody.